Okay, I'm going to do some of the homework on this video. I'm not going to do it all. It's a lot of homework. In fact, I would not recommend doing all of this unless you just really need the extra practice. I'll write in the announcements which ones you should be doing. We're going to start with 1A and 1B. So find the probability of our z-score being less than this negative 0.37. So they're already giving you the z-score. You just need to go look at the table. The table will automatically tell you the less than number. So negative 0.37. Here's negative 0.3 and 7. So all the way here at the end, 0.3557. 0.3557, and that's our answer right there, 35.57% of sort of the z-scores are less than that. So 1B, the point they're trying to make, they're using the same number. The table won't tell you, the percentage or the probability of it being greater than. But you need to just understand that since the table tells you the less than number, if I want to find the greater than number, I just take 100% and I subtract out the 35.57% on this side. That's going to give us 64.43%. So just, if you're ever asked for greater than, you need to find the z-score, look at the table, and then you have to subtract that number, like either subtract the decimal from 1 or subtract the percentage from 100. All right, we're going to do 2A and 2C next. So find the probability of our z-score being between these two things. All right, these take a lot of work. We already know the z-scores, though, so we just got to sort of go look at the table. Remember, the table is always going to tell us the less than. So for the negative 1.33, if I go look at my table, here's negative 1.3, 0.03 is right here, so it's going to be 0.0918. Or like 9.18% of our data is less than that. The table, well, it can also tell us about 1.65, but remember, it's always telling us less than. So if I go look at my table for 1.65, 1.6, 1.65, it's going to be all the way here, 0.9505. And then whenever you're doing these where you're trying to find sort of the middle, what is the percentage or the probability between these two numbers? You always take sort of the top one, the 1.65, and you subtract the bottom one from that. And the reason why we're doing that is, about 95% of our data is less than the 1.65, but we don't want all the data less than that. We just want it less than to this negative 1.33. Well, if this 0.0918 represents the percent less than negative 1.33, we just want to subtract that out from the 0.9505. If I put that in the calculator, I'm going to get 80.8587 or 85.87%. I'm going to do C as well, and I'll put all the answers up online, but I'm just skipping around here. So let's do the C. It's just very similar. Find the probability of both of these things. And again, we already know the z-score, so we just got to go look at the table. So the z is less than negative 2.05. I would go look at my table. 2.0 and 5 is all the way out here, so this point looks like 0.202. I'm going to do the same thing for the 0.78. Again, we already know the z-score, so we just got to look at the table. 0.78. This 0.7823. So here's 0.7, 0.08 right here, 0.7823. And again, same deal as 2A. You just want to subtract sort of the lower one from the bigger one. And that will tell you your probability or percentage of your data being between those two numbers. Okay, so number 3 sort of uses a word problem for this stuff. It says we got the scores on the adult intelligence test. This might be an IQ test. For 20 to 34-year-olds is normally distributed with a mean of 110 and a standard deviation of 25. What is the probability that someone scores a 165 or less? So we're basically trying to find the probability of an X less than or equal to 165. So we're going to want to convert this to a z-score. And then we're going to use our table to find the probability that the z-score is less than whatever number this z-score relates to. So we're going to find our z-score for 165. And so 165 minus 110 over 25. We can put that in the calculator. We're going to get 2.2. Okay. So it's a nice even 2.2. I'll say 2.20. We're going to go look at our table. Remember, the table automatically tells you the probability of it being less than that number. So 0.9861. So the probability of our z being less than 2.20 is that 0.9861. Well, that's what we wanted here. You know, this is the exact same inequality. This 2.20 just relates to that 165. It's just the z-score of that. So this is not only for the z-score, this also counts for our data less than 165. So our answer is 98.61%. Yeah, let's do number 4. So we got bags of potatoes averaging 10 pounds with a standard deviation of 0.5 pounds. Assuming this follows the normal curve, what percent of the bags weighed less than 10.25 pounds? So we're finding the probability that a bag was less than 10.25. So we're going to want to find the z-score for this. We'll say 10.25 minus 10 over our standard deviation of 0.5 is going to give us 0.5 for our z-score. We're going to go look at the table. Remember, the table tells you the probability of these z-values being less than or equal to 0.5. And it's the same symbol, it's the same inequality here. So whatever we get for this, it's going to relate back to this. It's going to be the same answer. So if I go look at my table, the 0.5 is 0.6915. Or 69.15%. And that's our answer. That's the same thing that this would be. What percent weighed between 9.5 and 10.25 pounds? We already found the 10.25 one, so the probability for the z-score for that one is 0.6915. We would need to do basically what we did on 2A and 2C for this. So go find the 9.5, find a z-score for that first, since it doesn't give us it. 9.5 minus 10 over 0.5 is going to be -1. And so if you go look at the table, it's going to tell you the probability of it being less than -1. So -1 is just an even -1. So -1.00 is 0.1587. And remember, when you're finding it between two values, you want to take sort of the bigger number, so the 0.6915 here, and we want to subtract out the smaller number. So we'll say 0.6915 minus 0.1587. And if I do that, I get 0.5328. Oh no. Or 53.28%. All right. I'm going to skip over number 5. I'll have that one worked out on the sheet, so you'll be able to see that. And I want to do number 6 down here, and then I'm going to stop from the homework. A normal distribution has a mean of 112.8 and a standard deviation of 9.3. Use the standard normal table to find the indicated probability for the randomly selected x value. Okay, this is just doing the same thing that we did on the word problems, only there's no words. Instead of us having to figure out what the probability is that we're trying to find, it's just sort of spelling it out for you right here. So if I want to find the probability that our data is greater than or equal to 90.9, and this is our mean and this is our standard deviation, we're going to find the z-score that goes with this first. So our z-score for 90.9, if I say 90.9 minus 112.8 over 9.3, I'm going to end up getting something like -2.35. If I go look at the table, remember the table is going to tell you the probability of it being less than. So of choosing somebody less than that z-score, or choosing some data less than that. So if I go do that, the -2.35 here is -2.3. The 0.5 is all the way out here, so it's going to be 0.0094. So that is our probability. So percent would be like 0.94% of choosing a value, of getting a value less than 90.9. But we want to know the probability of it being greater than 90.9. So the way we do this, you know, if it's not in percentage form, if it's in decimal form, do 1 minus 0.0094, and you're going to get 0.9906 or 99.06%. So that's the probability of getting a value greater than 90.9. If we had converted this to a percentage, if we had made this 0.94%, we would have just said 100 minus 0.94%. We would have gotten the same thing. All right, I'll have the workup for 7 and 8 and also for 9 as well, but that's all I'm going to do for this video. All right, have a good day.